Hi, let's demystify this physics UTME 2022 question on the AC circuit. It says a 5 microfarad capacitor is connected directly across a 250 root mean square voltage 120 Hz AC source. Find the peak value of the current. So we'll just start by writing out our parameters. So we have the capacitance of the capacitor given as 5 microfarad, which is 5 times 10 raised to the power minus 6 farad. Okay, that's micro is 10 raised to the power minus 6. And then we have our root mean square voltage is given. It's given as 250 volts. And then we have our frequency also given. The frequency is 120 hertz. Yeah, that's 120 hertz as the frequency. So we're looking for the peak value of the current, and that's I naught. So basically we need to look for a way to get right to this by getting all the formulas that connect, that will connect us to getting this based on what we've been given. All right, so let's start by recalling that I root mean square current, or rather I root mean square is equal to a peak current over square root of 2. Okay, so recall that this formula connects our peak current to this. So to get our peak current, it means that we'll cross multiply this. We'll have the square root of 2 times, root mean squared current. Okay, so basically we need our root mean square current to be able to get our peak current, but we do not have our root mean square current. So you also need to look for a formula that connects, this to what we have to be able to get it, so we can get our peak current. So let's recall from Ohm's law, V is equal to IR. So V root mean squared is going to be equal to I root mean squared times, because we have a capacitor in the circuit now, what we'd have is the capacitance, the capacitive reactance, that's XC. Excuse me, that's XC. Okay, so again, you've noticed we don't have our XC. So to be able to get our root mean square current, we also need this. So first of all, let's make our root mean square current the subject of the formula. So we have our root mean square current, which is what we need, will be equal to V root mean squared over capacitive reactance. So we also need to get our capacitive reactance. So capacitive reactance, recall that it is equal to 1 over 2 pi FC. Okay, so we need to get a capacitive reactance, put it here, to be able to get our root mean square current, and slot it in here to be able to get our this. Okay, we already have this given. So we just, once we get our root mean square current, we can slot it in here. We don't even need to do this. We just slot it in here, and then we'll get our peak current, and that will be it. Okay, so let's start by getting our capacitive capacitive reactance. Okay, so XC will be equal to 1 over, so we have let me redo this because I'm going to need that space. So let me do this. I'm going to need that space. So let me have this here. All right, so 1 over 2 times 3.142, that's our pi, times f, which is our frequency. Our frequency is 120 hertz, times C, the capacitance of the capacitor, which is 5 times 10 raised to the power minus 6. Okay, so this will now be equal to, now you have to punch this out on your calculator. Now recall that for UTME students, you'll be using an on-screen calculator, and an on-screen calculator doesn't have certain functions like raised to power something. Okay, so you need to improvise. You need to recall from your knowledge of indices that 10 raised to the power minus 6. If you move it up, it becomes 10 raised to the power 6. Okay, so that's basically writing this as 10 raised to the power 6 over, I'll multiply all this now to get what will be here. 2 times this times this times this, since I've taken this up. So that's what I'm going to do. So 2 times excuse me, 2 times 3.142 times 120 times 5 is equal to 3770. So let me put that down. 3770.4. Okay, and then recall that 10 raised to the power 6 is 1 million. So 1 million divided by this, that's what I'll quickly do. So 1 million divided by 3770.4, that will give me 26265.22. Okay, we can leave it to 2 decimal places. 0.22 ohms. Take note, that's the unit of capacitive reactance. Okay, so we have our capacitive reactance excuse me, we have our capacitive reactance. Now we have our XC as this, so we're going to take it back into this. Okay, now to get our root mean square current, so our root mean square current now, which we need, will be equal to our V root mean square, our root mean square voltage, which we have already as 250, over our capacitive reactance, which is 265.22. So we divide that. I'll do that on my calculator. So I have 250 divided by 265.22, and that's giving me here, I'm having 0.943. Okay, let me use 3 decimal places this time. 943 amperes. Okay, that's for the root mean square current. Okay, so now we can get our peak current. You see the connections, how we took this from this point all the way down to this point. So therefore our root mean square current, sorry, our peak current, which is what we're looking for, will be equal to square root of 2. If you like, you can punch that out. That will be 1 point, the square root of 2, 1.4142. Okay, 1.414 times our root mean square value, which is 0.943. 0.943. So if you multiply this, 1.414 times 0.943 is 1.333402. Okay, so that's 1.333402. 3 amperes, and that would be option A. Okay, all right, so that's how to tackle this problem. Okay, now I made a video on all the formulas that you need for AC circuit. You can check out the video. The link will be right up there. Thank you. Please subscribe to my channel.